Hello students, this is a continuation of 11.5a, recursive formulas for geometric sequences. So it's on page 165 if you're on honors, page 153 if you're in SM1 regular. And it says, use the recursive formula to write the first 5 terms of the geometric sequence. Identify the common ratio. So here it gives us on number 1, a1 equals 1. A to the n equals a to the n minus 1 times 4. So for this one, we're going to write our a to the 1 is 1. So our next term would be a2. So if I put n as 2, a to the 2 minus 1 is a1. So I'm putting 1 in right here for all of this times 4 is 4. Then I do a3, which is a3 minus 1, which is a2, 4 times 4 is 16. Next, we'll put 16 right here. We're 1, 2, 3. Now it's the 4th term. So again, we're taking the previous term, 16 times 4, and that's 64. Now for the last one, I don't think I can do it in my head, so I take my handy dandy calculator right here, and I'm going to say 64 times 4, and that is 256. So then I write 256 right there. Okay, so if you're going to identify the common ratio, you would put R equals 4, because that is what you're multiplying it by every time. Okay. So the next one on number 2, f of 1, and this is sequence notation right here with the a1 and the an's. Now if it's f of 1 and f of n, this is function notation, and we have to make sure we're familiar with both types of notations. So our first one always is going to be the first number. So that would be a1 or f of 1 equals 3. Okay. Then it says f of n equals f of n minus 1 times negative 1/2. So if we're going with the second term, so f of 2, so n is 2, f of 2 minus 1 is 1 times negative 1/2. So if I want to use a handy dandy calculator, I go 3 times 1 ABC2 negative equals negative 1.5. And I think the answer key is going to want that in they want it in improper fraction form, or you could put negative 1.5 if you wanted to for that one down there. And I didn't leave enough room to write that. So then we go to the third term. So that means we take the second term and we multiply it by negative 1/2. So I still have it in my calculator. I didn't clear it out. So all I do is go times 1 ABC2 negative equals 3/4. So this is 3/4. Okay. And then our next term, again, I left it in there, and I'm going to go times 1 ABC2 negative equals negative 3/8. And I write that in there. Notice that when you multiply by a negative number, first one's positive, negative, positive, negative. What do you think this last one's going to be? Okay, let's see. We put negative 3/8 times 1 ABC2 negative equals 3/16. It's positive, and you are correct. Oh, that's not the most beautiful thing, but just know that that's a 6. Oops. Okay, that's good enough. Okay, next it says identify the common ratio and write the recursive formula for the geometric sequences. Find the 7th term in the sequence. So we'll start off with number 5. And we have to find out what is going on. First of all, what r is. Oh, I forgot to identify what r was here. And we can say r equals -1/2 because that is what the common ratio is that you're multiplied by each time on that sequence. Okay, all right. Next, okay, number 5, the common ratio. If I'm not sure what it is, I take the second number and divide it by the first. So I could say 32 divided by 64 equals 0.5. And to convert it fraction to decimal, we're going to go second, second, and the arrow means fraction to decimal, and that will show me 1/2. So I know r is 1/2. Now we wouldn't put 2 because this has to be multiplication, not division. So again, it's going to be 1/2. Then the recursive formula, we put our first one, a1 equals 64. Okay, and then, I don't know if you can see it okay. Our recursive formula then is going to be a to the n equals our a to the n minus 1, the previous term, times our r, which is 1/2. And there you have that. And then it says find the 7th term. Okay, so I ran out of room here, so I'm going to put it over here. Okay, so we have our first 4. The first one is 64. Second one is 32. Third is 16. Fourth is 8. So it's times by 1/2, or in your mind you can divide by 2. So the fifth one will be 4. 6 is 2. 7th is 1. So you could say your a to the 7th, back over here, a to the 7th equals 1. And there you go. Okay. All right, now we're going to go for this other side. Where's number 8? Where it has 1, -1/2, 1/4, -1/8, comma, dot, dot, dot. And again, that's a 4. So what's our common ratio? Well, if it's negative, positive, negative, then we know, actually positive, negative, positive, negative, it starts at 1. We know that r equals, well, what times 1 makes -1/2 would be -1/2. Okay, so then the recursive formula would be, what's a1? Equals 1. And then a to the n equals a to the n minus 1 times, what is our r? -1/2. And then we need to find the last, or the 7th term in the sequence. Again, I'm going to go back to this, where our first term, maybe I'll have to use the black marker. Our first term is 1. Our second term is -1/2. Our third term, oops, couldn't see it. Our third term is 1/4. Fourth term is -1/8. Fifth term, okay. Again, if I'm multiplying by -1/2, I take the previous times by -1/2, and that's 1/16. Sixth term, I'm taking that, multiply by -1/2. That's -1/32. So then our 7th term times by -1/2, and we get 1/64. So then we go back to this, and we say f of 7 right here equals 1/64. And there you have that. Okay. Next, I'm going to go on to the next page, which is 166 in honors and 154 in regular classes. So what do you notice about number 11 on that next page? It's a graph, and if it's a geometric sequence, do you notice that it goes up exponentially? Okay, so I'm just going to put the numbers in the graph. If n is 1, f of n is 2. If n is 2, f of n is 4. Now, can you fill in the rest of this chart with the n equals 3, 4, and 5? So these are the terms. Okay, and this is 2, 4, and then what's the next one? And again, you could stop the video and fill this out if you would like. Okay, so we're going to identify the common ratio and write the recursive formula for the geometric sequences in sequence and function notation both. So we need to know how to do both. So a to the 1 equals 2. That's just saying a to the 1 equals 2. I'm going to also put f of 1 equals 2. Okay, so this is sequence notation, and this is function notation. So I can put a little thing down below, but a lot of things, what I'm going to get here is very similar to what I'm going to get there. Okay, so then I say a to the n equals a to the n minus 1 times 2. And that's our recursive formula in sequence notation. For function notation, I'm going to put f of n equals, and I might need to move it here, f of n minus 1 times by 2. Okay? All right, students, you can get the rest of this. You rock.